Imagine a world where modern humans were never the dominant species, a world where another branch of humanity survived, and we disappeared instead. They hunted, made tools, cared for one another, and adapted to brutal Ice Age landscapes. So just how close did they come to replacing us? Tonight we're uncovering the incredible story of the species that almost inherited the Earth, and the tiny twists of fate that changed human history forever. Before we begin, if you enjoy relaxing history, documentaries like this, please take a moment to like this video, subscribe to the channel, and join us for more fascinating journeys into humanity's forgotten past. Now let's travel back to the moment our closest rivals walked beside us. The wind carries powdered snow across an empty valley where the tracks are already disappearing. A herd of wild horses moves cautiously along the frozen grassland, their breath rising into the pale morning air before vanishing into a sky that seems impossibly large. Nearby, hidden among scattered boulders darkened by countless winters, another group is watching. They are patient, silent, and remarkably familiar. Their faces are broader than our own, their bodies shorter and stronger, their hands shaped by generations spent gripping stone, wood, and spear. They do not know that hundreds of thousands of years later they will become symbols of extinction. They simply know that today, like every other day, survival depends on reading the landscape better than anything else alive. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. For generations, people imagined human history as a simple ladder. Primitive ancestors slowly climbed upward until modern humanity finally appeared at the top, leaving everything else behind. It was a comforting story because it suggested that history always moved toward one inevitable destination. Yet almost every major discovery made during the last century has dismantled that picture piece by piece. Instead of a single ladder, the human past increasingly resembles an ancient forest, filled with many branches growing beside one another. Some flourished for astonishing lengths of time. Others vanished almost without leaving a trace. A few overlapped, exchanged ideas, crossed paths, and even shared families. Our own species is only one surviving branch of that forgotten forest. This realization transforms one of history's oldest assumptions. Modern humans were not always alone. There were long stretches of prehistory when multiple human species occupied the same planet. Some lived deep within tropical forests. Others crossed windswept grasslands or climbed mountain valleys buried beneath glaciers. Their worlds overlapped just enough to create encounters whose consequences still remain hidden inside the DNA, carried by billions of people today. Among all of these vanished relatives, one species stands apart. No other extinct human comes so close to resembling us in appearance, intelligence, adaptability, and endurance. They mastered some of the harshest environments ever occupied by humans. They survived dramatic climate swings that repeatedly reshaped continents. They thrived for hundreds of thousands of years before modern humans entered their territories. If history had unfolded only slightly differently, the familiar face looking back from every mirror today might not belong to Homo sapiens at all. That possibility feels unsettling because it forces an uncomfortable thought. Humanity's existence may never have been guaranteed. Roughly 500,000 years ago, the world was already changing in powerful cycles. Vast ice sheets advanced across northern lands before retreating once more. Rivers shifted course. Forests expanded, then disappeared beneath open steppe. Sea levels rose and fell by astonishing distances, exposing land bridges before swallowing them again. Every fluctuation demanded new strategies from the creatures attempting to survive. Some populations adapted remarkably well. Across Europe and Western Asia, descendants of earlier human ancestors gradually evolved into beings perfectly suited to cold climates. Their bodies became compact, conserving heat. Their limbs shortened, their bones thickened, massive muscles anchored themselves to broad shoulders capable of tremendous strength. Large noses warmed freezing air before it reached delicate lungs. Every feature reflected thousands of generations responding to unforgiving environments. Meanwhile, elsewhere across Africa, another population followed a different evolutionary path. Their environments demanded flexibility rather than specialization. Changing rainfall patterns encouraged movement. Expanding landscapes rewarded curiosity, cooperation, and adaptation across many different habitats. These populations would eventually give rise to Homo sapiens. For an extraordinarily long time, neither lineage knew the other existed. Separated by geography, climate, and immense stretches of time, each became successful according to its own conditions. There was nothing inevitable about which would ultimately survive. In fact, viewed from the perspective of much of prehistory, the northern species appeared astonishingly secure. Generation after generation hunted large Ice Age mammals, crafted sophisticated stone tools, controlled fire, cared for injured companions, and passed practical knowledge through countless winters. The evidence remains incomplete, but what survives in the archaeological record suggests lives far richer than earlier generations of researchers imagined. Broken bones that healed completely indicate individuals received care for months or even years after severe injuries that would have been fatal alone. Carefully selected stone carried over long distances reveals planning rather than simple instinct. Hearths repeatedly rebuilt inside caves hint at places remembered and revisited across generations. These are not isolated accidents. They reveal communities capable of cooperation on levels once believed unique to our own species. Even so, the landscape never becomes gentle. Every season brings fresh uncertainty. Mammoth herds alter their migrations. Reindeer follow shifting vegetation. Rivers freeze earlier than expected. Predators compete for the same prey. A successful hunt can feed families for days while repeated failures threaten entire groups. Knowledge becomes the most valuable resource of all. The ability to remember safe shelters, recognize changing weather, identify edible plants beneath snow, or predict animal movements often matters more than physical strength itself. It is easy to imagine prehistoric life as endlessly violent, yet much of it is instead shaped by patience. Hunters wait for hours in bitter winds. Children observe adults fashioning tools from carefully chosen stone. Elders preserve memories of dangerous valleys and reliable water sources. Skills accumulate gradually carried forward not through written language, but through observation, repetition, and trust. This ancient rhythm continues for thousands upon thousands of years. Across continents, glaciers advance and retreat. Volcanoes erupt. Entire ecosystems reorganize themselves. Species appear and disappear. Through every transformation, these humans remain remarkably resilient. Long before cities, kingdoms, or agriculture exist, they have already demonstrated that intelligence alone does not guarantee survival. Success depends upon fitting one's world, and for an immense span of time, few creatures fit Ice Age Eurasia better. Modern archaeology increasingly paints this forgotten world with surprising complexity. Caves once dismissed as simple shelters now preserve microscopic traces of daily activity. Ancient pollen reconstructs vanished forests. Animal teeth record seasonal migrations. Tiny fragments of charcoal reveal repeated occupations separated by centuries. Even the sediments beneath human footprints quietly preserve stories invisible to earlier generations of scientists. Each new discovery widens the picture while reminding researchers how much has vanished forever. Scholars still debate countless details because erosion time and changing climates have erased far more evidence than they preserved. Entire populations may have lived and disappeared without leaving recognizable traces, No single explanation fully accounts for every mystery hidden within this immense span of human history. Yet one truth grows increasingly difficult to ignore. Long before modern civilization, before pyramids, before writing, before the first villages appeared beside fertile rivers, another humanity had already built its own deep history across the Ice Age world. For hundreds of millennia they stood not as primitive failures awaiting replacement, but as one of evolution's greatest success stories. Only much later would another branch of the human family begin moving steadily toward the same landscape, setting the stage for one of the most extraordinary encounters our planet has ever witnessed. The first hints of this remarkable species appear not in a single dramatic moment, but across hundreds of thousands of years as Europe settles into the relentless rhythm of the Ice Age. Landscapes are repeatedly transformed. Dense forests give way to open grasslands before trees slowly reclaim the ground once more. Glaciers creep southward, grinding mountains into valleys, then retreat, as warmer centuries briefly soften the climate. Every cycle rewards those capable of adapting, and among the human population scattered across Western Eurasia, one lineage gradually becomes something distinct. The ancestors of the Neanderthals descend from earlier humans who have already lived in Europe for many generations. Isolated from populations remaining in Africa, they experience different environmental pressures. Evolution works quietly, almost invisibly through countless births and deaths. Individuals slightly better suited to surviving freezing winters leave more descendants. Over immense spans of time, those small differences accumulate until an entirely recognizable human species emerges. By around 400,000 years ago, many of the characteristics associated with Neanderthals are already taking shape. Their skeletons reveal extraordinary physical strength. Thick limb bones support heavily muscled bodies capable of enduring brutal conditions. Broad rib cages house powerful lungs. Large joints absorb the repeated strain of carrying heavy loads across uneven ground. Even their fingers show signs of constant demanding work, suggesting lives built around hunting, crafting, climbing, scraping hides, and maintaining tools. These features are sometimes mistaken for signs of primitiveness. Modern research paints a different picture. The Neanderthal body represents specialization rather than inferiority. Just as polar bears differ from tropical bears because they occupy different environments, Neanderthals reflect hundreds of thousands of years of adaptation to cold northern ecosystems. Their shorter limbs reduce heat loss. Their broad noses help warm frigid air before it reaches sensitive tissues. Their compact build conserves precious body warmth during winters that modern people would find nearly impossible to endure without advanced technology. The Ice Age world itself is far more varied than the endless snowfields often imagined. During colder periods, vast mammoth steppes stretch across enormous distances, supporting immense herds of grazing animals. Woolly mammoths move slowly across frozen plains. Woolly rhinoceroses browse among hardy shrubs. Steppe bison, horses, reindeer, musk oxen, and giant deer migrate, according to changing seasons. Wolves, cave lions, hyenas, and bears follow these herds, creating ecosystems unlike anything alive today. Neanderthals become masters of these changing landscapes. Their survival depends upon understanding patterns that unfold over months rather than days. They learn where rivers remain unfrozen longest. They remember which valleys shelter animals during harsh winters. They recognize subtle shifts in weather that announce approaching storms. What survives in the archaeological record suggests extraordinary familiarity with local environments, accumulated through generations of careful observation. Stone tools provide one of the clearest windows into their abilities. Earlier researchers often assumed prehistoric tools changed only slowly because their makers lacked imagination. That assumption has steadily disappeared. Neanderthals produce carefully planned toolkits. using sophisticated methods that require considerable foresight. Before striking the first blow, a skilled craftsperson mentally prepares the stone core, anticipating how flakes will detach to produce sharp cutting edges with remarkable efficiency. This technique, known today as the Levallois method, demonstrates abstract planning rather than random trial and error. A single carefully prepared stone core can yield multiple tools of predictable shape. Such craftsmanship requires experience, precision, and the ability to visualize results before they exist. These are unmistakably human qualities. Their use of raw materials also reveals surprising complexity. High-quality stone sometimes travels dozens or even hundreds of kilometers from its geological source. Scholars still debate exactly how this movement occurs. Some materials may pass through direct journeys. Others perhaps move gradually between neighboring groups through exchange networks that remain only partially understood. Whatever the mechanism, the evidence suggests, Neanderthal communities maintain broader connections than once believed. Fire becomes another essential ally. Maintaining reliable fire in Ice Age Europe is not merely a convenience, it is the difference between life and death. Hearths provide warmth, light protection from predators, and the ability to cook food more efficiently. Burned bones, charcoal, and layers of ash preserved inside caves indicate that many sites are occupied repeatedly across long periods. Families return to familiar shelters because generations before them have already proven those locations dependable. The caves themselves become more than temporary refuges. Some preserve evidence of organized living spaces. Areas devoted to tool-making remain separate from places where food is processed. Certain sections accumulate animal bones, while others contain concentrated hearth remains. Although scholars continue debating exactly how structured these settlements become, the pattern suggests thoughtful use of space rather than random occupation. Children grow within these demanding environments from the moment they are born. Their education leaves almost no direct archaeological trace, yet it can be reconstructed indirectly. Mastering complex stone technologies cannot happen by accident. Hunting dangerous prey requires coordinated teamwork. Knowledge of edible plants, medicinal resources, seasonal migration routes, and weather patterns must pass from one generation to the next. Young Neanderthals almost certainly spend years observing skilled adults before becoming capable hunters themselves. The evidence remains incomplete, but several discoveries hint at emotional bonds extending well beyond immediate survival. Skeletons of severely injured individuals show healed fractures, crushed limbs, missing teeth, and degenerative diseases. Some survive conditions that would have prevented them from hunting independently for months or even years. Their continued existence strongly suggests sustained care from relatives or companions willing to share food and protection despite the obvious costs. One elderly individual discovered in present-day Iraq survives blindness in one eye, serious hearing loss, and multiple injuries. Another lives despite the loss of an arm years before death. These people are not abandoned when they become less productive. Instead, someone continues helping them through countless seasons. Such discoveries quietly reshape long-standing assumptions about compassion in the prehistoric world. Neanderthal diets also prove far more flexible than early researchers imagined. Large game certainly provides an important food source, but microscopic plant remains trapped in fossilized dental plaque, reveal consumption of seeds, nuts, mushrooms, legumes, and cooked vegetation in several regions. Coastal populations gather shellfish. River communities exploit freshwater resources. Different groups adapt their diets according to local opportunities rather than following one rigid pattern. As scientific techniques improve, the picture grows richer still. Chemical signatures preserved within ancient bones reveal seasonal movements. Microscopic wear on stone tools identifies activities ranging from hide scraping to woodworking. Residues trapped on cutting edges preserve traces of plants once harvested thousands of generations ago. Every new method uncovers another layer of daily life that earlier archaeologists could scarcely imagine. Yet despite all this growing knowledge, enormous mysteries remain. Scholars still debate the full complexity of Neanderthal language, symbolic behavior, and social organization. The evidence points towards sophisticated minds, but many details disappear forever because spoken words leave no fossils, and wooden objects usually decay long before reaching the present. Even with these uncertainties, one conclusion becomes increasingly difficult to avoid. By the time Homo sapiens begins expanding beyond Africa, Europe, and Western Asia are not empty frontiers waiting to be settled. They already belong to experienced, intelligent, and highly adaptable people whose ancestors have thrived there for hundreds of millennia. Any newcomer entering these landscapes will not encounter wilderness alone. They will encounter another humanity, one perfectly at home in the frozen world that has shaped every generation of its existence. If survival alone measured success, Neanderthals would rank among the greatest achievements in human evolution. For more than 300,000 years, they persist through repeated Ice Age cycles that transform Europe and Western Asia beyond recognition. Entire forests advance and retreat. Rivers carve new valleys. Sea levels fluctuate by well over 100 meters. Animal communities reorganize again and again. Yet generation after generation, Neanderthal families continue finding ways to live within this shifting world. Their greatest strength is not simply physical power, it is an intimate understanding of place. A modern satellite can map mountains, rivers, and forests with astonishing precision, but Neanderthals carry a different kind of map inside their memories. Every valley holds information. Certain cliffs funnel migrating animals during autumn. Particular caves remain dry during spring floods. South-facing slopes lose their snow earlier, exposing edible roots and attracting grazing herds. Water emerging from limestone springs rarely freezes completely, making it reliable throughout harsh winters. Such knowledge cannot be gathered in a single lifetime. It accumulates over countless generations, passed carefully from elders to children through repeated experience. The Ice Age landscape rewards those who notice subtle changes. A slight shift in wind direction may reveal approaching reindeer before they become visible. Fresh wolf tracks crossing older mammoth prints hint at predator movements. Birds suddenly abandoning a valley sometimes signal weather changes hours before clouds gather overhead. These observations are neither accidental nor trivial. They represent survival distilled into instinct through hundreds of thousands of years. Large animals dominate much of the Neanderthal world. Mammoths tower over the plains, their curved tusks sweeping through snow to uncover buried vegetation. Woolly rhinoceroses graze with remarkable resilience despite freezing temperatures. Giant deer carry antlers stretching wider than many modern doorways. Steppe bison travel in powerful herds, while wild horses race across open grasslands where few trees interrupt the horizon. Hunting such animals requires extraordinary coordination. Older portrayals often imagine Neanderthals rushing recklessly toward dangerous prey with little planning. Modern archaeological evidence suggests something far more sophisticated. Hunting large Ice Age mammals almost certainly demands cooperation, patience, and careful knowledge of terrain. Hunters likely use valleys, ravines, river crossings, and natural bottlenecks to limit an animal's escape routes, before closing the distance with carefully crafted wooden spears tipped by sharp stone points. Several remarkably preserved wooden spears discovered in Europe, though associated with earlier human populations, demonstrate that sophisticated hunting technology exists long before modern humans arrive. Neanderthals inherit and refine many of these traditions. Their stone points reveal repeated maintenance and reshaping, suggesting valuable tools remain in use for extended periods rather than being discarded after every hunt. Success, however, is never guaranteed. Every confrontation with massive prey carries enormous risk. A single charging bison can break bones instantly. An injured mammoth may crush multiple hunters before collapsing. Even successful hunts demand exhausting labor afterward. Hundreds of kilograms of meat must be processed quickly before scavengers arrive or warmer weather causes spoilage. Hides require scraping. Bones are broken to reach nutritious marrow. Tendons become cordage. Antlers provide raw material for additional tools. Almost every part of the animal finds a purpose. This efficiency reflects necessity rather than abundance. Evidence from numerous archaeological sites indicates that Neanderthals waste very little. Cut marks on bones reveal systematic butchering techniques. Burned fragments suggest marrow-rich bones are roasted before being fractured. Stone flakes scattered nearby record repeated sharpening of cutting edges during the processing of enormous carcasses. What appears chaotic after thousands of years beneath the soil once represented organized purposeful activity, carried out by experienced hands. Fire remains at the center of daily existence. Around evening, hearths families likely repair tools, prepare hides, cook food and share practical knowledge accumulated during the day's travels. The archaeological record cannot preserve conversations, but it preserves the traces those evenings leave behind. Charcoal mixes with cracked bones. Tiny stone flakes accumulate where someone reshapes a knife. Burned seeds occasionally survive, revealing meals that combine meat with gathered plant foods. Every layer becomes another page in a story written without words. For decades, researchers assumed Neanderthals relied almost entirely upon meat. That view has steadily changed. Microscopic analysis of fossilized dental plaque has uncovered surprising remains of cooked starches, legumes, nuts, wild grasses, mushrooms, and medicinal plants. In some regions, traces of bitter herbs appear despite offering little nutritional value. Scholars still debate their purpose. Perhaps they are consumed for medicinal reasons. Perhaps they flavor food. The evidence remains incomplete, yet it points toward dietary knowledge far broader than earlier theories allowed. Another remarkable discovery comes from caves where residues suggest the controlled use of naturally occurring minerals. Red and yellow pigments appear at several Neanderthal sites across Europe. Whether these materials serve symbolic purposes, practical functions such as hide treatment or multiple roles remains actively debated. No single explanation fully accounts for every occurrence. Still, their presence reminds researchers that prehistoric behavior rarely fits simple categories. The Neanderthal brain itself continues challenging long-held assumptions. On average, cranial capacity falls within the range of modern humans, and sometimes even exceeds it. Brain size alone says little about intelligence, but it demonstrates that these people are not intellectually diminished versions of ourselves. Instead, their brains develop under different evolutionary pressures. Some researchers suggest greater investment in visual processing, and body control may reflect the demands of navigating rugged landscapes and coordinating close-range hunting. These ideas remain under investigation, yet they illustrate how different does not necessarily mean lesser. Perhaps the most moving evidence of Neanderthal society comes from those who can no longer contribute fully to the hunt. Across several archaeological sites, individuals survive devastating injuries that would have left them dependent upon others. Broken legs heal correctly. Crushed ribs mend over many months. Arthritic joints show years of continued life despite chronic pain. Dental disease becomes so severe that chewing must have been extremely difficult, yet individuals continue living long afterward. Such survival strongly implies regular assistance from companions, Willing to gather food, provide protection, and share limited resources, compassion therefore may not be a recent invention. It may have deep evolutionary roots stretching back far before recorded history. Caring for injured companions strengthens social bonds, preserves valuable knowledge, and improves group resilience. An elder unable to hunt may still remember migration routes followed decades earlier, or recognize weather patterns invisible to younger eyes. Experience itself becomes a resource worth protecting. Life expectancy nevertheless remains uncertain and often short by modern standards. Many children almost certainly die young. Accidents, infections, harsh winters, and unpredictable food supplies constantly threaten survival. Yet those who reach adulthood possess an extraordinary understanding of their world shaped by hardships almost impossible to imagine today. As centuries become millennia, Neanderthal communities continue adapting to landscapes that never remain stable for long. They endure glacial advances, warmer interludes, shifting forests, disappearing coastlines, and changing animal migrations. Few species demonstrate such resilience across such immense stretches of time. Looking only at their long record of survival, there is little reason to suspect that their dominance will ever end. Far to the south, however, another branch of the human family is also changing. Across the varied environments of Africa, Homo sapiens is developing its own remarkable strengths. Strengths shaped not by one harsh landscape, but by extraordinary ecological diversity. For thousands of years, the two lineages remain unaware of one another, separated by deserts, mountains, and immense distances. That separation cannot last forever. Slowly, almost imperceptibly, the paths of these two successful human species begin moving toward the same horizon. For nearly 300,000 years, the worlds of Neanderthals and Homo sapiens unfold along separate paths. Each lineage responds to different climates, different predators, and different opportunities. Neither exists as a failed version of the other. Both are successful in the landscapes that shape them. If someone living 100,000 years ago had been asked which human species appeared most secure, the answer would not have been obvious. Africa during this period is anything but stable. Rainfall patterns shift repeatedly as Earth's orbit and climate interact over tens of thousands of years. Grasslands expand across regions once covered by woodland before shrinking again beneath returning forests. Lakes appear where deserts later dominate, only to vanish as drying climates reclaim the land. These environmental changes encourage constant flexibility. Human populations move, divide, reconnect, and adapt to habitats ranging from coastal shorelines to mountain highlands and broad savannas. Within this dynamic setting, Homo sapiens gradually acquires characteristics that distinguish the species from every other member of the human family. Skeletons become lighter and more slender. Faces grow flatter. Brows become less pronounced. Chins appear for reasons that scholars still debate. The brain remains large, but subtle differences emerge in shape and organization. None of these changes alone explains what follows. Evolution rarely depends on a single transformative feature. Instead, numerous small adaptations accumulate until together they produce something new. Behavior begins changing as well. Stone technologies become increasingly varied across different African regions. Instead of relying upon one dominant approach for long periods, communities experiment with multiple techniques suited to local conditions. Bone tools appear more frequently. Carefully shaped points, blades, and specialized implements suggest growing versatility. Pigments become increasingly common at several archaeological sites, and pieces of engraved ochre hint that symbolic behavior is becoming more widespread, although scholars continue debating exactly how these objects were used. Along Africa's coastline, some communities discover rich marine resources. Shellfish fish seabirds and coastal plants supplement inland hunting. Reliable shoreline food may help certain populations survive periods when inland environments become less predictable. The evidence remains incomplete, but many researchers believe these diverse food sources contribute to greater resilience during climatic fluctuations. Social networks may also be expanding. Unlike isolated groups confined to a single valley, some Homo sapiens communities appear connected across surprisingly large distances. Similar styles of ornaments, pigments, and stone materials occasionally occur hundreds of kilometers apart. These patterns suggest that ideas, objects, or people themselves travel farther than previously assumed. Such connections could become critically important during difficult years. A struggling group might seek assistance from distant relatives or exchange partners rather than facing starvation alone. No single explanation fully accounts for the remarkable expansion that eventually follows, but broader social connections remain one of the leading possibilities. Then the climate begins opening unexpected pathways. Around 120,000 years ago, parts of northeastern Africa and the Arabian Peninsula become greener than today. Periods of increased rainfall transform sections of desert into landscapes containing rivers, lakes and grasslands capable of supporting both animals and humans. These favorable intervals create migration corridors that would otherwise remain almost impassable. Small groups of Homo sapiens begin exploring beyond Africa. Some early movements leave little lasting trace. Archaeological evidence indicates that several populations reach the eastern Mediterranean and nearby regions long before the great expansion that ultimately succeeds. Yet many of these pioneering communities appear to disappear or retreat as climates shift once more. Their stories end quietly, preserved only in scattered stone tools and a handful of fossil remains. These first journeys reveal an important truth. Human expansion does not occur as one unstoppable wave sweeping across continents. Instead, it unfolds through repeated attempts spread over tens of thousands of years. Some migrations fail completely. Others establish temporary populations that eventually vanish. Success comes gradually shaped by changing climates as much as by human decisions. While these exploratory movements continue, Neanderthals remain firmly established across Europe and Western Asia. Their territories stretch from the Atlantic coast eastward into parts of Central Asia. They know these landscapes intimately. Their ancestors have occupied many regions for hundreds of thousands of years. Familiar caves continue serving as seasonal shelters. Traditional hunting grounds remain productive. Rivers, forests, and open steppes still provide the resources needed for survival. Eventually, however, the two worlds begin to overlap. The exact locations of the earlier sustained encounters remain uncertain because the archaeological record is incomplete. Fossils are rare. Campsites are often destroyed by erosion or buried beneath later deposits. Nevertheless, discoveries from the Levant suggest that both Neanderthals and Homo sapiens occupy the region at different times, and perhaps occasionally during overlapping periods. This narrow geographical corridor becomes one of history's great crossroads linking Africa, Asia, and Europe. Imagine these landscapes not as empty wilderness, but as territories filled with signs invisible to outsiders, trails worn by migrating animals, springs known only to local groups, shelters repeatedly occupied over generations, sources of high-quality stone carefully remembered. Into this familiar world arrive newcomers carrying different traditions, different technologies, and perhaps different ways of organizing society. What happens next remains one of the greatest mysteries in human evolution. Popular imagination often envisions immediate warfare with two rival species battling for dominance across Ice Age Europe. The archaeological evidence tells a more restrained story. Direct proof of violent conflict is surprisingly limited. This absence does not mean conflict never occurred. Competition for food territory and resources almost certainly existed at times. Yet it also leaves room for other possibilities. Some encounters may have been cautious observations from a distance. Others may have involved temporary avoidance, each group choosing different hunting territories rather than risking confrontation. In certain places, exchange of knowledge or materials may even have occurred. The evidence remains fragmentary, but similarities in some stone tool traditions suggest that ideas occasionally pass between populations. Scholars still debate how extensive these interactions become, yet increasing evidence indicates that the relationship between the two species is more complex than simple hostility. Biology provides perhaps the strongest clue. If Neanderthals and Homo sapiens were entirely separate in every meaningful sense, modern genetics would tell a very different story. Instead, DNA preserved within ancient bones, and later found in living people, reveals that these encounters eventually become deeply personal. Long before kingdoms, writing, or agriculture, members of the two species form families together. At the time, of course, neither group possesses any concept of species in the modern scientific sense. They encounter individuals who look somewhat different but unmistakably human. The consequences of those meetings will remain hidden for tens of thousands of years until genetic technology uncovers them in the 21st century. For now, however, none of that future is visible. Across the valleys of Eurasia, two intelligent human species are beginning to share the same landscapes. One carries generations of experience in the frozen north. The other brings extraordinary flexibility forged across Africa's changing environments. Neither knows that history is approaching a turning point unlike anything their ancestors have ever experienced. The meeting has begun, but its outcome remains uncertain, balanced delicately between coexistence, competition, adaptation, and chance. For thousands of years after their first overlapping migrations, Europe and Western Asia become home to something that has happened only rarely in the history of our planet. Two intelligent human species occupy many of the same broad regions at the same time. They breathe the same cold air, follow many of the same migrating animals, drink from the same rivers, and shelter beneath some of the same limestone cliffs. Yet exactly how often they meet remains one of archaeology's most fascinating unanswered questions. The image of constant confrontation has gradually given way to something far more nuanced. The archaeological record suggests that direct encounters may actually have been relatively uncommon across much of the landscape. Human populations during the late Pleistocene are remarkably small by modern standards. Entire regions that today support millions of people may then have contained only a few scattered bands separated by days of travel. Vast stretches of forest, grassland, mountains, and frozen plains lie between them. This means that two neighbouring groups could live within the same general territory while rarely crossing paths. When they do encounter one another, the circumstances likely vary enormously. A hunting party may discover fresh footprints leading toward a valley they intended to enter. Smoke rising from a distant cave might reveal that another group has already occupied a familiar shelter. Carefully butchered animal remains could indicate recent activity nearby. Such signs would immediately communicate valuable information long before anyone came face to face. Avoidance may often be the safest strategy. In environments where survival depends upon limited resources, unnecessary conflict carries tremendous risks. Even a successful fight can leave experienced hunters injured, reducing the entire group's ability to survive the coming winter. Broken bones, infected wounds, or the loss of skilled adults may prove catastrophic for small communities. Choosing another valley or delaying a hunt by several days could be far wiser than engaging in violence. This possibility aligns with patterns observed among many traditional hunter-gatherer societies. Cooperation and caution often exist alongside competition. Territorial awareness does not automatically produce warfare. Instead, people continuously weigh the costs and benefits of every decision. Archaeological evidence increasingly hints that Neanderthals and Homo sapiens occasionally influence one another in subtle ways. Stone tool traditions provide one of the most intriguing clues. Around the period when the two species overlap, certain industry appear that combine characteristics once thought unique to different populations. One of the best-known examples is the Châtelperronian industry in Western Europe. Some archaeological sites associated with Neanderthal contain carefully crafted blades, bone tools, and ornaments that resemble technologies more commonly linked with early Homo sapiens. Scholars continue debating exactly how these similarities arise. Some researchers argue that Neanderthals independently develop comparable innovations in response to changing circumstances. Others suggest that ideas spread through direct observation or occasional contact between neighboring populations. Still others propose a combination of both processes. No single explanation fully accounts for every site, because the archaeological record remains uneven and preservation varies greatly across regions. Whatever the precise mechanism, the evidence increasingly challenges the outdated image of isolated prehistoric societies, incapable of learning from one another. Personal ornaments offer another fascinating window into this world. At several sites associated with Neanderthals, archaeologists discover eagle talons bearing cut marks, perforated animal teeth, carefully selected feathers and pigments that may have decorated clothing or bodies. These objects hold little practical value for hunting or survival. Instead, they suggest attention to appearance, identity, or social meaning. Exactly what those meanings are remains impossible to know. Modern humans often feel tempted to project familiar symbolic systems onto the distant past, but caution is essential. A feather worn today may symbolize something entirely different from one worn 50,000 years ago. Nevertheless, the deliberate collection and modification of visually striking materials indicate that Neanderthals engage with our world in ways extending beyond immediate physical necessity. The growing evidence for symbolic behavior narrows yet another perceived gap between ourselves and our closest extinct relatives. Food gathering also reveals remarkable flexibility. While large mammals remain central to many Neanderthal communities, archaeological discoveries continue expanding the known range of their diets. Coastal caves preserve shells from marine mollusks gathered along ancient shorelines. Burned fish bones appear at several sites. Small mammals, birds, tortoises, and edible plants supplement hunting whenever opportunities arise. These findings undermine the older stereotype of Neanderthals as inflexible specialists dependent upon only a handful of large prey species. Likewise, Homo sapiens entering Eurasia do not rely upon identical strategies everywhere. Some populations exploit river systems rich in fish. Others concentrate on open grassland hunting. Woodland communities develop different seasonal routines from those living along coasts. Adaptability becomes one of their defining characteristics. But Neanderthals also demonstrate far greater ecological flexibility than earlier generations of researchers once believed. As the picture grows more detailed, the differences between the two species become increasingly subtle rather than absolute. Both manufacture sophisticated tools. Both control fire. Both cooperate during dangerous hunts. Both care for injured companions. Both adapt to changing environments. Both transmit knowledge across generations. The question therefore becomes far more interesting than simply asking which species is better. Instead, researchers ask whether small cumulative differences almost invisible over short periods gradually produce enormous consequences across thousands of years. One possibility centers on population size. Genetic evidence suggests Homo sapiens populations may gradually become larger and more interconnected than many Neanderthal groups. Larger populations create important advantages even when individuals possess similar abilities. innovation spread more rapidly. Valuable knowledge survives the death of particular individuals. Exchange networks reduce the impact of local shortages. Communities recovering from disease or environmental disasters may receive newcomers from neighboring groups. Small isolated populations face greater challenges. A harsh winter volcanic eruption epidemic or repeated hunting failures can dramatically reduce their numbers. Once populations become sufficiently small, rebuilding becomes increasingly difficult, even if environmental conditions later improve. Every birth matters. Every death carries greater significance. These demographic differences remain an active area of research, and scholars still debate their precise importance. Yet many now believe that population structure rather than intelligence alone may play a central role in explaining the different fates of Neanderthals and Homo sapiens. Meanwhile, another extraordinary discovery waits tens of thousands of years in the future. When scientists first recover ancient Neanderthal DNA, they expect to reconstruct a completely separate evolutionary story. Instead, the genetic evidence reveals something astonishing. The relationship between these two human species is not limited to shared landscapes, overlapping technologies, or neighboring territories. At some point during these encounters, individuals from both groups form families together. Children are born carrying ancestry from each lineage. Those children survive. Their descendants continue living. Generation after generation, fragments of Neanderthal DNA pass quietly through countless families until they eventually become part of the genetic heritage carried by much of humanity today. Long before archaeologists uncover a single ancient genome, the evidence has already been travelling inside living people all across the world, waiting for modern science to reveal one of the deepest connections in human history. When the first draft of the Neanderthal genome was announced in the early 21st century, it transformed decades of debate almost overnight. For generations, scientists had argued over whether Neanderthals and Homo sapiens merely replaced one another, or whether their histories became intertwined. Bones alone could not settle the question. Similar skeletons might reflect shared ancestry rather than direct contact. Stone tools could spread between neighbouring groups without families ever forming. Archaeology hinted at possibilities, but genetics offered something far more definitive. The answer emerged from fragments no larger than grains of dust. Inside ancient bones preserved for tens of thousands of years, tiny pieces of DNA survived against extraordinary odds. Most genetic material had long since broken apart through natural chemical decay. Modern contamination threatened every sample. Laboratories had to develop entirely new techniques capable of distinguishing authentic ancient molecules from modern human DNA, accidentally introduced during excavation or handling. The process demanded patience measured not in days but in years. When enough fragments were finally assembled, researchers compared Neanderthal DNA with the genomes of living people from different parts of the world. The results were unexpected. If Neanderthals had disappeared without leaving descendants, their genetic signature should exist only in fossils. Instead, people whose ancestry lies primarily outside Africa consistently carry small percentages of Neanderthal DNA. Most individuals inherit roughly 1 to 2% of their genome from Neanderthal ancestors. Although the exact proportion varies between populations and individuals, the overall pattern remains remarkably consistent. This discovery changes the story forever. Neanderthals are not entirely lost. They survive quite literally within billions of living people. The implication is unavoidable. Somewhere in Western Asia, perhaps more than once and across multiple regions, members of the two species meet not merely as neighbours, but as partners. Children born from these unions grow to adulthood, have children of their own, and pass fragments of Neanderthal DNA into future generations. Those genetic fragments travel silently across tens of thousands of years, until modern laboratories finally uncover their presence. The encounters themselves remain almost invisible archaeologically. A single family leaves few traces distinguishable from countless other prehistoric campsites. Clothing decays, conversations vanish instantly, wooden shelters rot away. Yet DNA preserves what stone and bone alone cannot. It records relationships too personal to appear anywhere else in the archaeological record. Scholars continue debating exactly how often interbreeding occurs. Current evidence suggests it is not a single isolated event. Instead, several episodes of contact likely take place over thousands of years in different regions. Some genetic studies even indicate that small amounts of Homo sapiens DNA enter Neanderthal populations long before the better-known later exchanges. Human history proves far less one-directional than earlier theories imagined. These discoveries also reshape how scientists define species. Modern biology often describes species as populations that cannot produce fertile offspring together. Yet nature rarely follows perfectly rigid categories. Wolves and coyotes interbreed. Polar bears and brown bears occasionally produce fertile descendants. Many closely related species blur the boundaries created by human classification. Neanderthals and Homo sapiens appear to belong somewhere within this complex biological landscape. They remain clearly distinguishable populations with long, separate evolutionary histories, yet they are genetically compatible enough to produce descendants whose families continue through countless generations. Rather than existing as completely isolated branches, they resemble neighbouring limbs that briefly reconnect before separating again. Ancient DNA continues revealing surprises beyond simple ancestry. Some inherited Neanderthal genes appear to influence the modern immune system. As Homo sapiens enters Eurasia, they encounter unfamiliar diseases carried by animals and long-established human populations. Genetic variants inherited from Neanderthals may help some newcomers recognize pathogens already common outside Africa. In this sense, interbreeding could provide immediate evolutionary advantages. Other inherited genes affect skin hair or responses to sunlight. Different environments place different demands upon the human body. Populations living for hundreds of thousands of years in northern latitudes experience conditions unlike those near the equator. Certain Neanderthal genetic variants may contribute to adaptation under colder climates or changing daylight patterns, although researchers continue investigating exactly how these complex interactions operate. Not every inherited gene proves beneficial. Natural selection gradually removes many Neanderthal genetic variants from later Homo sapiens populations. Some appear linked to reduced fertility or other disadvantages when combined with predominantly modern human genomes. Others persist because they offer advantages or remain largely neutral. Over thousands of generations, evolution quietly edits this inherited legacy, preserving some fragments while eliminating others. The result is remarkable. Although each individual carries only a small percentage of Neanderthal ancestry, different people inherit different fragments. Collectively, when scientists compare genomes from millions of living individuals, they recover a substantial portion of the original Neanderthal genetic blueprint dispersed across humanity itself. It is almost as though an extinct species has hidden its archive inside another. Genetics also introduces entirely new mysteries. In two caves separated by vast distances, researchers recover evidence of individuals whose immediate parents belong to different human groups. One astonishing fossil from Denisova Cave in Siberia belongs to a young girl whose mother is Neanderthal, and whose father is Denisovan, another extinct human lineage. This single individual demonstrates that encounters between different human populations occur more frequently than once believed. Rather than isolated evolutionary branches living in perfect separation, prehistoric humanity increasingly resembles an interconnected web. Some populations remain isolated for long periods. Others meet briefly before separating again, Ideas spread, genes spread. Occasionally entire communities disappear while leaving descendants elsewhere. The deeper scientists look, the more complicated the story becomes. Yet an important caution remains necessary. Genetic inheritance does not imply that Neanderthals gradually transformed into Homo sapiens through widespread mixing. The overwhelming evidence indicates that Neanderthal populations eventually disappear as distinct communities. Their genetic contribution survives because relatively small numbers of Neanderthal ancestors become incorporated into expanding Homo sapiens populations before the independent Neanderthal lineage comes to an end. Exactly why that separate identity vanishes remains unresolved. Interbreeding explains why Neanderthal DNA survives. It does not explain why Neanderthal societies disappear. Some researchers argue that gradual absorption contributes to the process, especially where populations become very small. Others believe climate change, demographic pressures, competition for resources, or simple bad luck play larger roles. No single explanation fully accounts for every region or every archaeological site. The genetic revolution therefore answers one of history's greatest questions while simultaneously opening many new ones. Far from proving that Neanderthals were evolutionary failures, DNA reveals how astonishingly close they came to sharing the future with us. They were not so different that families could not form. They were not so distant that their biological legacy vanished. Their children walk the same landscapes as early Homo sapiens, carrying within them the inheritance of two human worlds. And that realization leads to an even deeper mystery. If Neanderthals were intelligent, adaptable, socially complex, capable of interbreeding with our own species, and successful across hundreds of thousands of years, then why did they disappear while Homo sapiens endured? The answer appears to lie not in one catastrophic event, but in the slow convergence of climate, population, and chance across an Ice Age world that was becoming less forgiving with every passing millennium. If history judged success by endurance alone, Neanderthals would hardly seem destined for extinction. By the time Homo sapiens begins establishing permanent populations across Western Eurasia, Neanderthals have already survived more than 300,000 years. They have endured repeated glacial advances, warmer interludes, volcanic eruptions, shifting coastlines, and dramatic ecological upheavals. Entire animal communities have appeared and disappeared while they continued adapting to one challenge after another. From that perspective, they appear almost invincible. It is tempting to search for a single defining advantage that eventually allows Homo sapiens to outlast them. Popular explanations have often focused on intelligence, suggesting that modern humans simply think more creatively or invent superior technologies. Yet as archaeological discoveries accumulate, that neat distinction becomes increasingly difficult to defend. Neanderthals are not merely capable hunters. They manufacture sophisticated stone tools requiring careful planning. They exploit a wide range of natural resources. They control fire with remarkable consistency. They care for injured companions over long periods. They adapt to changing climates repeatedly across vast stretches of time. They even leave behind evidence suggesting symbolic behavior in several regions. These are not trivial achievements. They represent capacities once considered uniquely modern. Instead of asking why Neanderthals fail, many researchers now ask a more revealing question. What combination of small differences gradually tilts the balance in favor of Homo sapiens? The answer may begin with flexibility rather than superiority. Neanderthals excel within the environments they know best. Across the cold grasslands, wooded valleys, and rugged hills of Ice Age Europe, their accumulated knowledge is unmatched. They understand seasonal migrations with astonishing precision. They recognize the subtle behavior of local prey species. They know where reliable shelter can be found when winter storms arrive unexpectedly. Homo sapiens enters these landscapes carrying a different evolutionary history. Rather than specializing for one dominant environment, populations emerging from Africa have adapted across deserts, tropical forests, coastlines, river systems, mountains, and open savannas. This long exposure to ecological diversity may encourage a broader range of behavioral responses when unfamiliar challenges arise. The evidence remains incomplete, but archaeological patterns increasingly suggest that Homo sapiens frequently modify hunting strategies, settlement patterns, and resource use more rapidly as local conditions change. This flexibility becomes particularly important during unstable climatic periods. The late Pleistocene is not a world of gradual, predictable change. Climate sometimes shifts with astonishing speed. Within only a few generations, forests can retreat, grasslands expand, rainfall patterns alter, and familiar migration routes disappear. Communities that have relied upon certain prey for centuries suddenly face entirely new conditions. Neither human species escapes these disruptions. Both must constantly adapt. Yet larger and more interconnected populations may possess important advantages when responding to rapid environmental uncertainty. Imagine two neighboring valleys. In one lives a relatively isolated Neanderthal community. They possess generations of local expertise but maintain limited contact with distant groups. If repeated hunting failures, disease, or severe winters reduce their numbers, recovery becomes increasingly difficult. Every experienced hunter lost represents decades of accumulated knowledge disappearing forever. In the neighboring valley, a Homo sapiens community belongs to a broader regional network. Relatives, trading partners, or neighboring groups exchange materials, information, and occasionally people. A failed hunting season remains dangerous, but assistance or migration from surrounding populations may reduce the long-term impact. New ideas spread more easily. Useful innovations travel farther. Small local disasters become less likely to erase entire communities. This demographic advantage may seem subtle. Over decades, it produces little obvious difference. Over thousands of years, however, it can become decisive. Mathematical models developed by population scientists support this possibility. Small, isolated populations face greater risks from random events alone. A single epidemic, an unusually harsh winter, or several years of poor reproduction can push numbers below sustainable levels. Once populations shrink sufficiently, recovery becomes increasingly uncertain, even if environmental conditions later improve. Genetics reinforces this concern. Ancient Neanderthal genomes reveal relatively low genetic diversity compared with many Homo sapiens populations. This finding suggests that Neanderthal communities are often smaller and more isolated. Low diversity itself does not cause extinction, but it can reduce resilience when new diseases emerge or environmental pressures intensify. Some regions provide particularly striking evidence. Late Neanderthal populations appear increasingly fragmented. Communities become separated by expanding forests, changing river systems, or deteriorating habitats. Contact between neighboring groups may grow less frequent. Isolation quietly magnifies every other challenge already facing them. Meanwhile, Homo sapiens continues expanding. This expansion is neither perfectly smooth nor universally successful. Some settlements fail, others disappear completely. Yet the overall pattern remains one of gradual growth across increasingly large territories. Different groups occupy different ecological niches, reducing direct competition within their own species, while increasing the likelihood that successful adaptations spread across wider regions. Technology also begins changing in subtle but meaningful ways. Homo sapiens toolkits often include greater numbers of specialized implements designed for particular tasks. Fine blades, bone needles, fishing equipment in some regions, and more elaborate composite tools become increasingly common. These developments do not suddenly revolutionize survival overnight, nor are they entirely absent among Neanderthals. Instead, they gradually expand the range of available responses to changing conditions. Clothing may illustrate this advantage. Both species undoubtedly wear animal hides in cold climates. Yet carefully shaped bone awls and needles associated with later Homo sapiens populations suggest increasingly fitted garments capable of providing better insulation. During severe winters, even modest improvements in clothing can reduce energy expenditure, improve mobility, and increase survival. Food storage presents another possible difference. Direct evidence remains scarce because organic materials rarely survive for tens of thousands of years. Nevertheless, some researchers argue that Homo sapiens communities may preserve and transport food more efficiently, allowing greater resilience during periods when fresh hunting proves unsuccessful. Scholars still debate the extent of these practices, but the possibility fits broader patterns of behavioral flexibility. None of these individual advantages appears overwhelming. Taken separately, each seems almost insignificant. Slightly broader exchange networks, marginally larger populations, incrementally more flexible technologies, occasional improvements in clothing, small increases in dietary diversity, greater movement of information across communities. Any one factor alone seems insufficient to explain the disappearance of an entire human species. Together, however, they begin forming a cumulative pattern. Evolution rarely favors dramatic transformations appearing overnight. More often, countless small advantages accumulate quietly across hundreds of generations. Tiny differences in survival rates, birth rates, or successful migrations eventually reshape continents without any single decisive moment. Yet even this growing list may still be incomplete, because another force entirely beyond human control is preparing to reshape the Ice Age world once again. Climate has challenged Neanderthals throughout their existence, but the environmental instability approaching during the final stages of their history may prove unlike anything their ancestors have previously endured. As temperatures fluctuate with increasing intensity, and familiar ecosystems begin breaking apart, both human species face trials that neither intelligence nor strength alone can fully overcome. The climate of the late Pleistocene does not change gently. It surges between colder and warmer phases with surprising speed, transforming entire regions within the span of a few human lifetimes. To modern observers accustomed to relatively stable conditions over historical timescales, it is difficult to imagine landscapes shifting so dramatically. Yet for Neanderthals and early Homo sapiens, environmental uncertainty is simply part of existence. Every generation inherits a world slightly different from the one their grandparents knew. Ice sheets spread across northern Europe, reflecting sunlight back into space and reinforcing colder conditions. Sea levels fall as enormous quantities of water become locked within expanding glaciers. Coastlines migrate outward by many kilometers, exposing vast plains that later disappear beneath rising oceans. Rivers alter their courses, lakes emerge and vanish. Forests retreat before advancing grasslands, only to return centuries later when temperatures recover. Every living creature must respond. The mammoth steppe, one of the most productive ecosystems of the Ice Age, supports astonishing numbers of grazing animals across enormous distances. Dry windswept grasslands stretch from Western Europe deep into northern Asia. Woolly mammoths browse among hardy vegetation. Steppe bison graze in great herds. Wild horses, reindeer, musk oxen, and saiga antelope migrate across landscapes where survival depends upon constant movement. Neanderthals know these environments intimately. For hundreds of thousands of years, they have followed seasonal rhythms shaped by migrating animals and predictable ecological patterns. Their hunting strategies, settlement choices, and annual movements become deeply connected to these familiar cycles. Stability, even within a harsh climate, allows knowledge accumulated over countless generations to remain valuable. Then the rhythm begins to break. Climate records extracted from Greenland ice cores reveal episodes of remarkably rapid warming followed by renewed cooling. Some temperature shifts occur over only a few decades, an astonishing pace in geological terms. Vegetation zones move north or south. Animal populations adjust their migrations or disappear from certain regions entirely. Habitats that support human communities for centuries become unreliable with surprising speed. What survives in the archaeological record suggests that Neanderthals repeatedly respond to these challenges. Communities relocate, tool traditions evolve, dietary flexibility increases in some areas, settlement patterns shift alongside changing ecosystems. These responses demonstrate resilience rather than helplessness. Yet repeated environmental disruption gradually places increasing pressure upon populations that are already relatively small and scattered. Different regions experience these changes differently. Southern Europe often becomes a refuge during especially cold periods. Peninsulas such as Iberia, Italy, and parts of the Balkans retain milder climates capable of supporting forests and diverse wildlife, even when northern regions become far less hospitable. As conditions deteriorate elsewhere, both animals and humans increasingly concentrate within these ecological refuges. This concentration carries consequences. Groups that once occupy enormous territories become compressed into smaller areas where resources are shared among growing numbers of competitors. Hunting grounds overlap more frequently. Familiar migration routes change. Local ecosystems must support increasing pressure from predators, including humans. Competition does not necessarily mean warfare. It can emerge quietly through overlapping resource needs. If two communities depend upon the same seasonal herd or the same sheltered valley during winter, one group's success may unintentionally reduce opportunities available to the other. Neither side needs to engage in direct conflict for ecological competition to shape long-term survival. Meanwhile, Homo sapiens continues expanding into regions long occupied by Neanderthals. Unlike a sudden invasion, this expansion unfolds gradually across thousands of years. Small groups establish themselves in favorable environments before later populations spread farther. Some settlements fail, others endure. The result resembles the slow filling of a landscape rather than a single dramatic conquest. The archaeological evidence increasingly suggests periods when both species inhabit neighboring regions for extended durations. This prolonged coexistence is important. If Neanderthals disappear immediately after Homo sapiens arrive, direct replacement becomes the obvious explanation. Instead, overlapping occupations lasting several thousand years imply a far more complicated process. Both species prove capable of surviving side by side despite environmental instability. Their eventual divergence therefore requires deeper explanation than simple first contact. Climate likely amplifies every existing vulnerability. Imagine a Neanderthal community occupying a familiar valley for generations. Local herds provide dependable food, nearby forests supply firewood, reliable springs remain unfrozen throughout winter. Then several unusually harsh decades alter vegetation patterns. Preferred prey become less common. Rivers freeze differently. Competing predators increase. A neighboring Homo sapiens group arrives drawing upon some of the same resources. None of these changes alone guarantees failure. Together, however, they gradually reduce resilience. A poor hunting season leaves fewer stored resources. A severe winter increases mortality among children and elders. A smaller population produces fewer births. Knowledge disappears with every experienced adult lost. Recovery becomes increasingly difficult. Population models suggest that repeated small setbacks can prove more dangerous than one catastrophic disaster. Communities rarely collapse overnight. Instead, they slowly lose the ability to recover from ordinary hardships. Eventually, even modest environmental fluctuations become overwhelming. Because too few individuals remain to absorb additional losses, ancient DNA appears consistent with this picture. Later, Neanderthal populations show signs of increasing isolation. Genetic diversity declines further in several regions, suggesting fewer opportunities for exchange between communities. Small isolated populations face greater risks from inbreeding disease and random demographic fluctuations. Scholars continue debating the precise contribution of these factors, but together they paint a picture of growing fragility. The changing climate also affects the animals upon which Neanderthals depend. Some large herbivores shift their ranges northward during warmer intervals. Others decline locally as vegetation changes. Forest expansion reduces open grasslands favored by certain prey species. Communities highly familiar with one ecological system must repeatedly learn another. Even exceptionally adaptable hunters face limits when the landscape itself transforms. Homo sapiens experiences the same environmental upheaval, yet broader exchange networks may help buffer these disruptions. Information about changing conditions can spread across wider territories. Groups encountering successful new hunting strategies or unfamiliar food resources may pass that knowledge to distant relatives. Population movement becomes another form of adaptation. Again, the evidence remains incomplete. Archaeology rarely preserves conversations, seasonal decisions, or failed migrations. Scientists reconstruct these processes from scattered campsites, fossil pollen, ancient animal bones, stone tools, and genetic evidence separated by thousands of years. Every new discovery refines the picture while reminding researchers how much has vanished forever. No single explanation fully accounts for the disappearance of Neanderthals. Climate alone cannot explain why Homo sapiens survives. Competition alone cannot explain why coexistence lasts so long. Interbreeding alone cannot explain why distinct Neanderthal communities eventually vanish. Instead, the evidence increasingly points toward multiple interacting forces, each strengthening the others over many generations. By around 50,000 years ago, the balance is beginning to shift. Neanderthals remain remarkable survivors, but their world is becoming smaller, more fragmented and less predictable. Across Europe, familiar territories are breaking apart into isolated pockets separated by expanding ecological barriers. The greatest challenge they have ever faced is no longer one harsh winter or one dangerous hunt. It is the gradual disappearance of the stable world that has sustained their people for hundreds of thousands of years. The disappearance of the Neanderthals does not arrive with a single dramatic catastrophe. There is no final battle preserved in the archaeological record, no unmistakable layer of ash covering every settlement, and no single climate event that instantly erases an entire species. Instead, the evidence points towards something quieter and in many ways more haunting. Their world contracts slowly, almost imperceptibly, until one isolated community after another fades from history. For generations, Neanderthal bands continue occupying territories that their ancestors have known for thousands of years. Familiar caves remain seasonal shelters. Hunting routes are followed as they always have been. Children still learn where fresh water emerges from limestone cliffs, where reindeer cross narrow valleys, and which sheltered slopes lose their snow first each spring. Yet something has changed. The distances between neighbouring communities appear to grow larger. Ancient DNA recovered from late Neanderthal individuals suggests populations become increasingly fragmented. Small groups are separated by mountains, forests, changing climates, and expanding territories occupied by Homo sapiens. Opportunities for meeting unrelated partners become less frequent. Exchange of ideas, materials, and genetic diversity gradually declines. This isolation creates problems that are not immediately obvious. A community numbering only a few dozen individuals may survive for years if conditions remain favourable. But such a small population possesses very little margin for error. One severe winter, one disease outbreak, one failed hunting season, one accident claiming several experienced adults. Each event removes a significant percentage of the entire community. Modern population biology describes this as demographic vulnerability. Random events that barely affect large populations can devastate very small ones. A society of several thousand people can absorb occasional losses without threatening its future. A group of 30 or 40 individuals cannot. Every birth becomes critically important. Every death leaves a gap that is difficult to replace. The archaeological record increasingly reflects this shrinking world. Many regions once occupied by Neanderthals gradually fall silent. Caves that preserve evidence of repeated habitation over tens of thousands of years suddenly show no further signs of occupation. Stone tool traditions become geographically restricted. Population centres retreat toward ecological refuges where climate remains comparatively stable. Southern Europe becomes especially important during these final millennia. The Iberian Peninsula, parts of Italy, Croatia, and the southern Balkans appear to shelter some of the last surviving Neanderthal communities. These regions offer milder conditions than much of northern Europe during colder climatic phases. Forests, rivers, and diverse animal populations continue supporting human life, even as harsher environments expand elsewhere. For a time, these refugees provide hope. Communities adapt as they always have. They continue hunting. They continue making tools. They continue raising children. Life goes on. Yet the surrounding world continues changing. As Homo sapiens populations become more widespread, ecological space grows increasingly limited. This does not necessarily imply violent displacement. Rather, the cumulative demands of two intelligent hunter-gatherer species occupying overlapping landscapes gradually reduce the flexibility available to each local community. Imagine a valley capable of supporting one hunting band comfortably. If another group begins using neighboring territories, both communities may still survive. But unexpected environmental pressures, a drought, a harsh winter, declining prey populations leave far less room for adjustment. Areas once available as alternatives may already be occupied. The pressure builds gradually. No single season proves decisive. Decade after decade, however, repeated challenges accumulate. Evidence from animal remains reflects changing ecosystems as well. Some prey species decline regionally. Others alter migration routes. Forests expand into open hunting grounds during warmer intervals, favoring different animals and requiring different strategies. Neanderthals repeatedly demonstrate their ability to adapt, but adaptation itself carries costs. New techniques must be learned. Traditional knowledge loses some of its value. Every environmental transition demands additional flexibility. Meanwhile, Homo sapiens populations continue growing. Larger populations generate another subtle advantage. Innovation rarely depends upon one exceptional individual. Instead, it spreads through many connected communities. If one group discovers a more effective hunting strategy, improved clothing design, or new method of processing food, neighboring communities may adopt the idea before it disappears. Large social networks preserve knowledge more reliably than isolated populations. Neanderthal communities becoming increasingly fragmented may lose this advantage. Useful innovations can vanish simply because the few people possessing them die before passing their knowledge onward. The evidence remains incomplete, but demographic models consistently suggest that population size alone can influence long-term survival, even when competing groups possess similar intelligence and technological abilities. One particularly intriguing line of evidence comes from cave occupations. Several caves in France, Spain, and Croatia preserve some of the latest confirmed Neanderthal remains. These sites reveal people still living remarkably familiar lives despite mounting pressures. Stone tools continue to be crafted with skill. Animal bones show effective hunting and butchering. Hearths provide warmth exactly as they have for countless generations. Nothing about these final communities suggests a species that has forgotten how to survive. Instead, they resemble experienced people confronting circumstances that have gradually become less forgiving. Some researchers compare this process to an old tree standing within an increasingly changing forest. The tree itself remains healthy. Its roots remain deep. Its branches continue producing leaves, but surrounding conditions slowly become less favorable until regeneration becomes impossible. Eventually, the final tree falls not because it suddenly becomes weak, but because the entire ecosystem supporting it has changed. The same principle may apply to Neanderthals. Their disappearance likely reflects the cumulative interaction of many pressures rather than one overwhelming cause. Climate instability, small population size, habitat fragmentation, reduced genetic diversity, competition for resources, occasional interbreeding, random demographic events. Each factor alone seems insufficient. Together they gradually narrow the possibilities for long-term survival. The exact timing of their disappearance remains an active area of research because improved dating techniques continue refining archaeological chronologies. Earlier studies often suggested surprisingly late survival at several sites. More recent analyses have revised some of those dates, indicating that contamination or methodological limitations affected earlier conclusions. Even so, the broad pattern remains consistent. By approximately 40,000 years ago, unmistakable evidence for independent Neanderthal populations disappears from the archaeological record. Their caves continue existing. Their hunting grounds remain. Their rivers keep flowing toward distant seas. But the people who once knew every hidden path through those landscapes are no longer there. Only scattered traces remain behind. A stone scraper discarded beside a hearth. A child's tooth buried beneath ancient sediments. The healed bones of an elder who survived injuries through the care of companions. Charcoal marking the place where a family once gathered against the cold. None of these discoveries records the final moment. There is no last known Neanderthal standing alone before an advancing world. Instead, extinction arrives quietly, one community at a time, until eventually no living group remains, to preserve the traditions carried across more than 300,000 years of remarkable human history. Yet their story is far from finished. Even after their disappearance as a distinct people, clues continue waiting beneath cave floors, inside forgotten sediments, and within the genetic inheritance of modern humanity. Decades after archaeologists believe they understand the Neanderthals' revolutionary scientific techniques, begin uncovering entirely new evidence that not only reshapes their history, but transforms our understanding of what it means to be human. Long after the last Neanderthal community disappears from the archaeological record, their story seems complete. Museums display heavy-browed skulls beside carefully crafted stone tools. Textbooks describe a close evolutionary relative that flourishes for hundreds of thousands of years before fading into extinction. For much of the 20th century, the broad outline appears settled. Then science begins asking entirely new questions. Instead of looking only at visible fossils, researchers start examining invisible evidence hidden within the sediments surrounding them. Ancient pollen reconstructs vanished forests. Microscopic charcoal reveals long-forgotten fires. Chemical signatures locked inside teeth preserve information about childhood diets and seasonal movements. DNA itself, once thought impossible to recover from deep prehistory, becomes one of archaeology's most powerful tools. The result is nothing short of revolutionary. Every major advance seems to reveal another layer of Neanderthal life that had remained hidden for tens of thousands of years. One of the earliest breakthroughs comes from stable isotope analysis. Bones preserve subtle chemical differences depending upon the foods an individual consumes during life. By measuring specific isotopes of carbon and nitrogen, scientists can estimate the relative importance of meat freshwater resources or plant foods in prehistoric diets. Early results confirm that many Neanderthal populations occupy high positions within their ecosystems, consuming large quantities of animal protein similar to top predators. Yet this picture soon becomes more complicated. Dental plaque mineralized deposits preserved on ancient teeth contains microscopic remains of plants, fungal spores, starch granules, and even traces of smoke. These tiny particles survive where larger organic materials have long since decayed. Suddenly, researchers discover evidence that Neanderthals eat a far broader range of foods than previously recognized. Different communities consume different diets. Those living near coastlines gather shellfish and occasionally exploit marine resources. Woodland groups collect nuts, mushrooms, and edible roots. Others process wild grasses or legumes. Some even appear to use bitter medicinal plants with little nutritional value, suggesting knowledge extending beyond simple hunger. The evidence remains incomplete, but it steadily dismantles the old stereotype of Neanderthals as inflexible big-game hunters, incapable of adapting their diets. Microscopic wear patterns on teeth tell another story. Everyday activities leave distinctive scratches and polish on enamel. Some Neanderthals regularly grip hides, fibers, or plant materials between their teeth, while working with their hands using the mouth almost like an additional tool. These subtle marks reveal repeated behaviors that no stone artifact could ever preserve. Technology itself also receives fresh examination. High-powered microscopes identify microscopic damage along stone tool edges. Certain wear patterns indicate hide scraping. Others reveal woodworking. Some tools cut meat. Others process plants. Individual implements often perform multiple functions before being resharpened again and again. Rather than carrying dozens of specialized tools, Neanderthals frequently maximize the usefulness of each carefully crafted object. Excavations become increasingly sophisticated as well. Earlier archaeologists often remove sediments in relatively thick layers, unintentionally overlooking tiny clues. Modern excavations proceed centimeter by centimeter, sometimes millimeter by millimeter. Every fragment of charcoal, pollen shell, or animal bone is carefully recorded. Computer mapping reconstructs the exact location of every artifact. Entire campsites begin reappearing in astonishing detail. Researchers identify where hearths once burned. They distinguish butchering areas from tool-making locations. They recognize sleeping spaces separated from refuse deposits. Even the direction in which stone flakes scatter during tool production helps reconstruct the movements of individuals who lived tens of thousands of years ago. Ancient DNA pushes these discoveries even further. Scientists no longer require complete skeletons to detect prehistoric populations. Tiny fragments of genetic material survive within cave sediments themselves. Soil collected from ancient occupation layers sometimes preserves enough DNA to reveal whether Neanderthals denisovans, bears, wolves, or other animals once occupied a site even when no visible bones remain. This technique transforms archaeological exploration. Caves previously thought empty suddenly reveal hidden chapters of human occupation. Entire populations become detectable through microscopic traces left behind in sediments. One particularly fascinating discovery concerns family relationships. By comparing ancient genomes recovered from multiple individuals, researchers begin reconstructing prehistoric kinship networks. At one Siberian cave associated with Neanderthals, genetic evidence identifies close relatives living within the same community. Some individuals are fathers and daughters, others are cousins or more distant family members. For the first time, prehistoric people begin emerging not merely as isolated fossils, but as members of recognizable families. These findings humanize the archaeological record in unexpected ways. A child's tooth no longer represents only one ancient individual. It belongs to someone's daughter, someone's grandson, someone who grows up beside familiar faces, learns from experienced elders, and shares daily life with people whose relationships can occasionally still be reconstructed through genetics. Scientific advances also reshape understanding of Neanderthal health. Tiny grooves preserved in tooth enamel record episodes of childhood stress caused by illness or food shortages. Microscopic bone structures reveal periods of interrupted growth. Chemical analyses identify repeated nutritional challenges alongside evidence of recovery. Life is difficult, but resilience remains remarkable. Researchers even detect ancient pathogens. Although direct evidence remains limited, ongoing studies continue exploring how infectious diseases influence prehistoric populations. Some scientists propose that expanding Homo sapiens populations may introduce unfamiliar diseases into regions occupied by Neanderthals. Others argue that both species already share many pathogens through overlapping environments and occasional interbreeding. Scholars still debate the significance of disease because evidence remains incomplete. No single epidemic has yet been identified as the cause of Neanderthal extinction, and most researchers consider disease only one possible contributing factor among many. Dating techniques improve dramatically as well. Radiocarbon analysis becomes increasingly precise through refined calibration methods. Additional techniques using uranium series dating, luminescence, and other approaches allow archaeologists to build far more accurate chronologies. Some famous sites once believed to preserve the very last Neanderthals are reassessed, revealing that contamination or earlier methodological limitations produced misleading dates. Far from weakening the story, these corrections strengthen scientific confidence. Knowledge advances because researchers continuously test previous conclusions rather than accepting them permanently. Perhaps the greatest lesson emerging from these technological revolutions is one of humility. Nearly every generation has believed it finally understood the Neanderthals. Nearly every generation has later discovered that the picture was incomplete. New methods reveal unexpected diets. New methods uncover hidden populations. New methods reconstruct ancient families. New methods detect invisible DNA. Each breakthrough reminds scientists that the prehistoric world still holds countless secrets beneath layers of soil that have remained undisturbed since the Ice Age. Yet one mystery grows even larger as evidence accumulates. The more researchers learn about Neanderthals, the harder it becomes to dismiss them as an evolutionary dead end. They're intelligent, adaptable, socially connected, technologically capable, and genetically intertwined with ourselves. Their extinction no longer appears inevitable. At the same time, another surprising realization is taking shape. Neanderthals are not the only human relatives whose stories have been hidden beneath the surface. Across Asia, inside a remote Siberian cave, scientists are about to uncover evidence of an entirely different human lineage. One that remained completely unknown until a fragment of bone no larger than a finger forever changed the human family tree. For more than a century, the human family tree appears relatively straightforward. Fossils reveal Neanderthals in Europe and Western Asia, Homo sapiens emerging from Africa, and a series of earlier ancestors stretching back millions of years. Each new discovery adds branches to the tree, but its overall structure remains familiar. Then, in a remote cave tucked within the Altai Mountains of southern Siberia, a discovery smaller than a child's finger begins rewriting the entire picture. The fossil itself seems almost insignificant. It is only the tip of a finger bone accompanied by a few isolated teeth recovered from layers of sediment deep inside Denisova Cave. No complete skeleton exists. No dramatic skull emerges from the earth. Had these remains been uncovered a few decades earlier, they might have been catalogued as belonging to an unknown human without attracting unusual attention. Instead, researchers extract DNA. The results astonish everyone. The genetic material does not match Neanderthals. It does not match Homo sapiens. It belongs to an entirely separate branch of humanity previously unknown to science. These people become known as the Denisovans, named after the cave where they are first identified. Their discovery demonstrates something extraordinary. Even after more than a century of archaeological exploration, an entire human lineage has remained invisible, simply because its fossil record is so fragmentary. The implications reach far beyond one cave. If a previously unknown human population can remain hidden until the 21st century, how complete is our understanding of prehistoric humanity? The answer increasingly is that it remains surprisingly incomplete. Unlike Neanderthals, whose physical appearance can be reconstructed from numerous skeletons, Denisovans remain elusive. Only a handful of bones, several teeth and fragments of jaw have been confidently identified. Yet genetically, they become one of the best understood extinct human populations ever studied. DNA reveals that Denisovans are closely related to Neanderthals, sharing a common ancestor hundreds of thousands of years earlier. After separating, however, each lineage follows its own evolutionary journey. While Neanderthals dominate much of Europe and Western Asia, Denisovans spread across enormous portions of Asia. Exactly how far they travel remains uncertain. Evidence suggests they occupy environments ranging from the freezing Altai Mountains to warmer regions much farther south. One remarkable jawbone discovered on the Tibetan Plateau indicates that Denisovans successfully inhabit high-altitude environments, where oxygen levels challenge even modern humans. This adaptation becomes one of the most fascinating examples of prehistoric evolution. Modern Tibetan populations possess a genetic variant that helps the body function efficiently at extreme elevations. Genetic analysis reveals that this adaptation originates not within Homo sapiens themselves, but through ancient interbreeding with Denisovans. Once again, extinct human relatives quietly survive within living people. Just as Neanderthal genes persist among many populations outside Africa, Denisovan ancestry appears in people across parts of Asia and Oceania. The highest proportions occur among indigenous populations of Papua New Guinea and several Pacific islands where Denisovan genetic contributions can reach several percent. These discoveries fundamentally change how scientists view human evolution. Instead of one successful species replacing every earlier population in sequence, the evidence increasingly resembles an intricate network of overlapping migrations encounters and genetic exchanges. Different human groups separate for hundreds of thousands of years before meeting again. Sometimes they compete. Sometimes they avoid one another. Occasionally they form families whose descendants survive into the present. The human story becomes far less linear than anyone once imagined. Even more remarkable is the discovery of one young individual whose remains preserve perhaps the clearest evidence of these encounters. Recovered from Denisova Cave, her tiny bone fragment belongs to a teenage girl who lived roughly 90,000 years ago. Genetic analysis reveals that her mother is Neanderthal while her father is Denisovan. She is not a distant descendant of mixed ancestry accumulated over countless generations. She is a first-generation child born directly from parents belonging to two different human lineages. This single discovery transforms speculation into undeniable reality. Interbreeding between different human populations is not an exceptionally rare accident occurring once across evolutionary history. It happens often enough that researchers recover direct evidence from one of the very few fossils available. The implications continue expanding. If Neanderthals, Denisovans, and Homo sapiens all exchange genes at different times and in different places, prehistoric Eurasia resembles a landscape inhabited by multiple, intelligent human populations whose histories intersect repeatedly. Each lineage develops unique adaptations. Each carries valuable genetic traits. Each contributes something to the future. Some contributions survive only through inherited DNA. Others vanish entirely. Meanwhile, archaeologists continue searching for physical evidence capable of matching these genetic revelations. Recent discoveries in China, Laos, and elsewhere hint that additional fossils may belong to Denisovans or closely related populations. Some researchers even suggest that certain mysterious Asian fossils represent branches not yet fully understood. Scholars still debate many of these identifications because fossil evidence remains limited. and DNA rarely survives in warm climates where preservation is poor. This uncertainty reminds scientists how uneven the archaeological record truly is. Europe preserves many Neanderthal remains partly because cool conditions favor fossil survival. Tropical forests, by contrast, rapidly destroy organic material. Entire populations may have lived, adapted, and disappeared without leaving recoverable skeletons. In such environments, absence of evidence cannot automatically become evidence of absence. The possibility remains that other human lineages once existed beyond those already recognized. Most would likely have been small populations occupying restricted regions. Some may eventually be identified through ancient proteins preserved where DNA no longer survives. Others may emerge from new excavation techniques capable of detecting microscopic traces previously overlooked. The human family tree, therefore, remains a work in progress. Every new discovery possesses the potential to redraw its branches. Yet among all these remarkable relatives, Neanderthals still occupy a unique position. They remain the closest extinct humans to ourselves in both anatomy and behavior. They share our landscapes longer than any other known lineage. They leave descendants living today, and for hundreds of thousands of years they stand as perhaps the only human species capable of matching Homo sapiens across much of Eurasia. Their disappearance, therefore, becomes even more profound. It is not merely the extinction of another prehistoric population. It marks the end of a world where multiple kinds of humans coexist. For millions of years, the Earth is home to several human species at once. By the end of the late Pleistocene, only one remains. Whether that outcome reflects superior adaptability, fortunate timing, demographic resilience, or simple chance continues to be debated. The evidence increasingly suggests that no single explanation fully accounts for the survival of Homo sapiens. History is often shaped not by one decisive moment, but by countless small events whose combined effects only become visible after thousands of years. Looking back across hundreds of thousands of years, it becomes increasingly difficult to escape one remarkable conclusion. Homo sapiens did not inherit an empty world. The landscapes that eventually became home to every civilization, every language, and every empire were once shared with other forms of humanity. Neanderthals walked the valleys of Europe. Denisovans occupied vast stretches of Asia. On isolated Indonesian islands, smaller-bodied human relatives adapted to environments unlike any found elsewhere. Our own species was not the first to spread across continents, nor was it the only one capable of remarkable achievements. The deeper archaeology reaches into the past, the more crowded the human story becomes. One of the most extraordinary discoveries arrives from the Indonesian island of Flores. In 2003, archaeologists excavating Liangbua Cave uncover the skeleton of an adult female unlike anything they expected. Standing only a little over 1 meter tall with a remarkably small brain yet unmistakably human anatomy, she belongs to a species eventually named Homo floresiensis. Newspapers quickly nickname her the Hobbit. The popular comparison captures public imagination, but it risks obscuring the scientific importance of the discovery. Homo floresiensis is not a mythical creature. It is a genuine human species that survives on Flores until surprisingly recent times, perhaps as little as 50,000 years ago. Although scholars continue refining the exact chronology, its existence challenges long-held assumptions. For decades, researchers believed that increasing brain size inevitably accompanied human evolution. Yet Homo floresiensis demonstrates that evolution follows no predetermined direction. Living in long isolation on an island with limited resources, its ancestors appear to undergo a process known as island dwarfism, becoming progressively smaller over many generations. Island environments often produce unexpected evolutionary outcomes. Large animals frequently shrink because food is limited. Small animals sometimes grow larger because predators are scarce. Flores itself preserves evidence of tiny elephants known as stegodonts, alongside giant rats, enormous storks, and the famous diminutive humans. Evolution once again refuses to follow simple rules. Despite their modest stature, Homo floresiensis manufactures stone tools, hunts local animals, and survives successfully within its island environment for an immense span of time. Their intelligence cannot be judged solely by brain size. Behavior matters, adaptation matters, survival matters. Elsewhere in Southeast Asia, another surprising discovery emerges. In Callao Cave on the Philippine island of Luzon, archaeologists identify fragmentary remains belonging to Homo luzonensis. Although only a few bones and teeth survive, they reveal yet another distinct human lineage occupying island environments during the late Pleistocene. The evidence remains incomplete, but Homo luzonensis appears to combine anatomical features unlike those of either Homo sapiens or Neanderthals. Again, the human family becomes more complicated. Each new discovery weakens the outdated vision of one inevitable evolutionary march toward modern humanity. Instead, different populations experiment with different solutions to survival. Some become large, some become small, some specialize for cold climates, others adapt to tropical forests, mountains, coastlines, or isolated islands. Each represents a successful response to particular ecological circumstances. Success, however, proves temporary. Climate changes, sea levels rise, habitats disappear, competition increases, chance intervenes. No species survives forever. The archaeological record suggests that between roughly 50,000 and 40,000 years ago, several of these human lineages vanish within a relatively compressed span of geological time. Homo floresiensis disappears. Homo luzonensis disappears. Neanderthals disappear. Denisovans fade from the record as distinct populations, although their descendants continue through interbreeding. Only Homo sapiens remains widespread. At first glance, this pattern invites a simple explanation. Perhaps modern humans are simply superior. Yet such certainty dissolves under closer examination. Each extinct lineage survives successfully for extraordinary periods before Homo sapiens expands into many of the same regions. Neanderthals endure for more than 300,000 years. Denisovans occupy vast portions of Asia. Island species adapt to environments where modern humans initially possess no obvious advantage. These are not evolutionary failures waiting to be replaced. They are long-lasting experiments shaped by different ecological pressures. Some scientists therefore caution against interpreting survival as proof of inherent superiority. History often favors flexibility, but it also rewards timing and fortune. Consider the enormous climatic instability of the late Pleistocene. A population thriving during one environmental phase may struggle dramatically when ecosystems reorganize. Another population arriving slightly later encounters entirely different conditions. Chance determines which valleys remain productive. Chance influences volcanic eruptions, severe droughts, disease outbreaks, and migration opportunities. Evolution never guarantees fairness. Modern humans themselves experience moments when extinction appears frighteningly possible. Genetic studies suggest that Homo sapiens passes through several population bottlenecks during its history. At certain points, the number of breeding individuals becomes surprisingly small. Had circumstances differed only slightly, our own lineage might have joined the growing list of vanished human species. This realization transforms how many researchers view Neanderthal extinction. Instead of asking why they fail while we succeed, they increasingly ask why our species survives while so many others do not. The distinction matters. Failure implies deficiency. Survival may instead reflect resilience combined with favorable circumstances. Some of the qualities often celebrated as uniquely human cooperation, adaptability, curiosity, planning, compassion, are increasingly visible among Neanderthals as well. Differences certainly exist. Population structure differs. Exchange networks differ. Technological trajectories differ. Yet the gap separating the species appears narrower with every new discovery. The greatest difference may not lie within individuals but within societies. Larger interconnected populations preserve innovations more effectively. Knowledge spreads farther. Communities recover more readily after local disasters. Small isolated groups, however capable, face greater long-term risks. This principle extends beyond prehistory. Many later civilizations flourish for centuries before environmental pressures, political fragmentation, disease, or demographic decline gradually weaken them. Collapse rarely results from one cause. Instead, multiple interacting forces slowly erode resilience until recovery becomes impossible. Neanderthal history may represent one of the earliest examples of this broader pattern. Their disappearance therefore carries lessons reaching far beyond human evolution. It reminds us that intelligence alone does not guarantee permanence. Adaptation must continue because environments never remain fixed. Even the most successful societies can become vulnerable when familiar conditions change more rapidly than expected. For hundreds of thousands of years, Neanderthals master one of the harshest worlds ever inhabited by humans. Their eventual disappearance does not diminish that achievement. If anything, it makes it more remarkable. They come closer than any other known human species to sharing the future with us. And had only a handful of variables unfolded differently, the dominant humanity of the modern world might have carried a very different face. It is natural to look back at prehistory knowing the ending and assume that Homo sapiens is always destined to prevail. After all, modern cities, satellites, written history, and billions of living people all seem to confirm that our success is inevitable. Yet this confidence exists only because we stand at the end of the story rather than inside it. Viewed from 45,000 years ago, the future is far less certain. Imagine walking across the cold grasslands of Ice Age Europe with no knowledge of what lies ahead. The landscape is immense, stretching beyond the horizon beneath changing skies. Herds of horses and bison move across the plains. Mammoths leave enormous footprints in frozen ground. Wolves follow at a distance. Smoke rises from caves scattered among limestone cliffs. Some of those fires belong to Homo sapiens. Others belong to Neanderthals. Neither group can possibly know which lineage will still exist thousands of generations later. To the people living through these years, survival depends entirely on tomorrow's hunt, the coming winter, and the health of their families. The distant future holds no meaning because it cannot be imagined. Modern hindsight creates the illusion of inevitability. Scientists often describe this tendency as survivorship bias. We naturally focus on the lineage that survives because it is the one capable of telling the story. Every extinct branch loses its own voice. No Neanderthal tradition survives to describe how they viewed the newcomers entering their territories. No Denisovan elder leaves behind an account of changing landscapes or unfamiliar neighbours. Their perspectives vanish with them. Only archaeology remains to speak on their behalf. This creates an important challenge. Archaeologists reconstruct entire worlds from scattered fragments. A broken spear point, a child's tooth, traces of charcoal pollen, preserved in ancient mud, microscopic wear on stone tools, faint chemical signatures locked inside fossil bones. Each clue is valuable. Each clue is incomplete. Together they reveal remarkable patterns, yet they also remind us how much has disappeared forever. Entire generations have left no identifiable traces. Countless conversations vanished the moment they ended. Songs, stories, laughter, fears, hopes, and memories dissolved into silence without leaving fossils behind. The surviving record is astonishingly rich. It is also astonishingly small. This realization encourages humility. For much of the 20th century, Neanderthals were portrayed as unintelligent brutes, because researchers possessed limited evidence and interpreted it through the assumptions of their own time. Then better excavations uncovered sophisticated tools. Ancient DNA revealed interbreeding. Microscopic analysis exposed diverse diets. Chemical studies reconstructed migration patterns. Each technological advance overturned previous certainty. What seems obvious today may appear incomplete tomorrow. Science progresses precisely because it expects revision. The Neanderthal story illustrates this process beautifully. Every major breakthrough has made them appear less alien and more familiar. They bury or deliberately place their dead in some circumstances, although scholars continue debating the exact meaning of these discoveries. They manufacture adhesives by heating birch bark under controlled conditions, an unexpectedly complex process requiring careful temperature management. They exploit local plants for food and perhaps medicine. They organize cooperative hunts. They care for injured companions. They produce ornaments and use pigments at several sites. None of these behaviors alone makes them identical to Homo sapiens. Taken together, however, they reveal minds operating with remarkable sophistication. At the same time, Homo sapiens continues developing strengths of its own. Long-distance exchange networks become increasingly extensive. Symbolic traditions diversify. Art flourishes in ways more abundantly preserved within the archaeological record. Technological specialization accelerates. Population numbers gradually increase. The differences between the two species become matters of degree rather than absolute categories. Both are unmistakably human. One simply proves slightly more resilient across changing circumstances. Even that conclusion requires caution. Some researchers argue that if climatic instability had followed different patterns, Neanderthal populations might have recovered. Others suggest that a few thousand additional individuals in critical regions could have dramatically altered demographic trajectories. Computer simulations repeatedly demonstrate how small initial differences often produce enormous long-term consequences. History balances on surprisingly narrow margins. A single successful migration, a sequence of favorable seasons, an epidemic that never occurs, a volcanic eruption arriving decades earlier or later. Any of these events can redirect evolutionary history in ways impossible to predict. Our own existence may therefore depend upon countless moments of chance, extending far beyond anything our ancestors consciously control. This perspective does not diminish human achievement. Instead, it deepens appreciation for the fragile chain of survival linking every generation to the next. Every person alive today descends from uninterrupted lines of individuals who survive famine, disease, predators, environmental disasters, accidents, and countless other threats stretching back through hundreds of thousands of years. The same is true of Neanderthals until eventually it is not. Somewhere perhaps in southern Iberia, or another isolated refuge whose identity remains uncertain, a final generation grows up never knowing it will be the last. Children learn familiar hunting routes. Adults repair tools beside evening fires. Elders remember landscapes now changing beyond recognition. Life continues as it always has. No ceremony marks the approaching end. No announcement declares that history is closing one branch of the human family forever. Communities simply become smaller. Distances between groups grow greater. Fewer children survive. Fewer neighbors arrive. The traditions that once stretched across continents gradually contract into isolated pockets. Then one community disappears, later another. Eventually there is no one left to teach the next generation. Extinction often arrives not with violence but with silence. This quiet ending carries extraordinary emotional weight precisely because Neanderthals come so close to enduring. Had a relatively small number of communities survived into the beginning of agriculture, human history would be unimaginably different. Cities might eventually arise in landscapes shared by two intelligent human species. Trade could occur between different branches of humanity. Cultural exchange might reshape both societies. Questions of identity, language, cooperation, and conflict would extend beyond anything known in recorded history. The evidence gives no indication that such a future ever comes close to reality, yet the possibility reminds us how contingent our own world truly is. Among every extinct human lineage known today, none approaches that alternative future more closely than the Neanderthals. They survive the longest beside us. They resemble us most closely. They leave descendants within us, and for hundreds of thousands of years they stand as perhaps the strongest alternative humanity our planet has ever known. There is a temptation whenever history presents a mystery to imagine an alternative ending. What if one battle had ended differently? What if one empire had never collapsed? What if one explorer had chosen another route? In the case of the Neanderthals, however, the alternative reaches much deeper than politics or geography. It touches the very definition of humanity itself. Imagine a world in which Neanderthal populations never shrink beyond recovery. This is not an exercise in fantasy, but in careful scientific reasoning. Any plausible alternative must begin from what archaeology, genetics, and paleoanthropology already tell us. Neanderthals are intelligent. They form stable social groups. They cooperate during hunts. They care for injured companions. They manufacture sophisticated tools. They adapt repeatedly to changing climates. Most importantly, they are biologically compatible with Homo sapiens. Those facts alone make them unique among our extinct relatives. Suppose that several larger Neanderthal populations survive the climatic instability that affects Europe around 40,000 years ago. Instead of becoming fragmented into isolated refuges, they maintain stronger connections across southern Europe and western Asia. Larger population sizes preserve genetic diversity. Knowledge continues flowing between neighboring groups. Environmental recovery allows their numbers to stabilize rather than decline. The first farmers arriving thousands of years later would not enter an empty continent inhabited only by their own species. Instead, they might encounter another humanity. Agriculture itself could unfold differently. The earliest farming societies depend upon expanding villages, predictable harvests, and long-distance exchange. Stable Neanderthal communities occupying nearby territories might become trading partners, competitors, or cautious neighbours. Archaeology offers no evidence that Neanderthals ever develop agriculture independently before their disappearance, but surviving populations would have tens of thousands of additional years in which to observe and potentially adopt new practices. Human innovation rarely spreads in only one direction. Throughout recorded history, technologies moved between neighbouring cultures regardless of language ancestry or political rivalry. Metalworking, pottery, navigation, domesticated animals and crops all cross cultural boundaries repeatedly. If Neanderthals survive into the Neolithic period, it is reasonable to expect that at least some ideas would eventually pass between the two species. Language presents another fascinating possibility. We still do not know exactly how Neanderthal speech sounds. The anatomy of the hyoid bone structures within the ear and genes associated with language suggest they possess sophisticated vocal communication, though scholars continue debating its full complexity. Whatever form their language takes, prolonged coexistence with Homo sapiens would almost certainly encourage bilingual communities in regions where contact remains frequent. History already provides countless examples of neighbouring peoples learning one another's languages for trade diplomacy or family life. There is little reason to assume prehistoric humans would behave differently. Intermarriage would likely continue as well. Genetic evidence already proves that such unions occur during the late Pleistocene. If both populations remain numerous, mixed communities might gradually become more common. Over many millennia, entirely new cultural identities could emerge, shaped by ancestry from both lineages. Yet coexistence would not necessarily be peaceful. Recorded human history demonstrates that competition often accompanies cooperation. Neighbouring societies trade valuable goods while simultaneously competing for territory. Alliances shift. Conflicts arise. Periods of stability alternate with moments of violence. There is no reason to assume relations between Homo sapiens and surviving Neanderthals would escape these familiar patterns. Environmental pressures would continue influencing both populations. Harsh winters, failed harvests after the development of agriculture, epidemic diseases, or expanding settlements might intensify competition for resources. Political structures could emerge very differently depending upon whether governments attempted to integrate, exclude, or coexist with another intelligent human species. Questions that modern societies ask about identity would become immeasurably more complex. What defines humanity? Would legal systems recognize both species equally? Could leadership extend across mixed communities? Would cultural traditions remain separate or gradually blend together? These questions cannot be answered because history follows another path, yet they reveal how profoundly Neanderthal survival would reshape civilization. Science itself would also look different. Natural philosophers of the ancient world might study living Neanderthals instead of reconstructing them from fossils. Classical scholars could describe anatomical differences directly. Medical traditions might compare two closely related forms of humanity. The very concept of what it means to be human would evolve along entirely different intellectual foundations. Religion, philosophy, and art would almost certainly reflect this shared existence. Myths might include both lineages not as monsters or strangers, but as neighbouring peoples with distinct histories. Artists could portray two recognizable human forms working together or living apart. Literature might explore relationships crossing biological boundaries that modern history never experiences. Yet perhaps the greatest change would occur within our own minds. Modern humanity often defines itself through uniqueness. We speak of human intelligence, human culture, human creativity, and human civilization, as though only one version of humanity has ever existed. A surviving Neanderthal population would permanently challenge that assumption. Children would grow up knowing another human species personally rather than imagining it through museums. Difference would become part of everyday life rather than distant prehistory. Ironically, such familiarity might ultimately deepen appreciation for both lineages. Each would preserve evolutionary solutions shaped by hundreds of thousands of years of separate history. Each would contribute distinct traditions, ecological knowledge, and cultural perspectives. The world would become richer for that diversity. Of course, none of this occurs. The archaeological record offers no convincing evidence that Neanderthals survive into recorded history. Their independent communities disappear thousands of years before agriculture spreads widely across Europe. The cities of Mesopotamia rise without them. The pyramids are built without them. The Roman Empire expands across landscapes where Neanderthal fires once burned unaware that another humanity had occupied those valleys for hundreds of millennia. Only scattered bones remain hidden beneath caves. Only fragments of DNA survive inside our own genomes. Only stone tools quietly wait beneath layers of sediment until archaeologists uncover them again. Yet this imagined alternative serves an important purpose. It reminds us how narrow history's path truly is. The difference between our world and one shared with another human species may rest upon countless small events accumulated over thousands of years, rather than one decisive turning point. That realization makes the actual story even more extraordinary. The species that came closest to replacing us never truly disappeared completely. Its independent societies vanished, but part of its biological legacy continued travelling forward through our own ancestors, ensuring that something of the Neanderthal still walks the earth today, hidden within the people who inherited fragments of their ancient world. The closer the evidence is examined, the more the familiar story begins to reverse itself. For generations, Neanderthals are presented as a failed experiment in human evolution, a primitive cousin destined to disappear as soon as modern humans arrived. Today, that interpretation has become increasingly difficult to defend. Archaeology, genetics, climate science, and anthropology now reveal a far more complex reality, one in which the outcome is anything but inevitable. If another human species truly came closest to replacing us, it was not because it nearly conquered the world through overwhelming strength or superior intelligence. It came closest because for an astonishing span of time, it succeeded at being human in its own way. For more than 300,000 years, Neanderthals occupied one of the harshest regions inhabited by any member of the human family. They survived repeated glacial cycles that reshaped entire continents. They adapted to changing forests, expanding grasslands, shifting coastlines, and fluctuating animal populations. They developed technologies suited to their environments, cared for vulnerable members of their communities, and passed practical knowledge across thousands of generations. Very few species accomplish such longevity. Measured purely by time, Neanderthals remain one of the greatest evolutionary success stories our lineage has ever produced. Their disappearance, therefore, deserves careful interpretation. The archaeological evidence increasingly suggests that no single explanation fully accounts for what happened. Climate instability repeatedly transformed their world. Small and fragmented populations became vulnerable to random demographic events. Genetic diversity gradually declined in many regions. Homo sapiens expanded across the same landscapes, while maintaining broader social networks and in many places larger populations. Occasionally the two species formed families together, leaving a biological legacy still carried by millions of people today. Each factor mattered. None acted alone. The story is not one of simple replacement. It is one of gradual convergence, environmental pressure, demographic chance, and extraordinary resilience tested over thousands of years. Perhaps the greatest lesson lies in what this history reveals about evolution itself. Evolution does not reward perfection. It rewards adaptation to present circumstances. A species perfectly suited to one world may struggle when that world changes. Another species possessing slightly greater flexibility, larger populations or broader exchange networks, may gradually gain advantages that become visible only after countless generations. Nothing about this process guarantees fairness. The Earth has witnessed the disappearance of dominant predators, giant mammals, ancient forests, coral reefs, and entire ecosystems that once seemed permanent. Extinction is not reserved for weak organisms. Often it claims those whose environments change faster than their ability to respond. Humans are no exception. Looking backward through deep time, Homo sapiens survives every challenge, not because failure is impossible, but because enough ancestors continue adapting despite overwhelming uncertainty. At several points in our own history, genetic evidence suggests our numbers become surprisingly small. We too experience moments when extinction appears entirely plausible. Had only a handful of migrations failed? Had climatic shifts unfolded differently? Had isolated populations remained separated for longer? Had disease spread along another route? The surviving branch of humanity might have looked very different, or there might have been no surviving branch at all. This perspective changes the meaning of success. Instead of viewing Homo sapiens as the inevitable destination of evolution, we become one fortunate lineage among many remarkable relatives. Neanderthals, Denisovans, Homo floresiensis, Homo luzonensis, and other extinct humans each represent successful responses to particular landscapes and ecological pressures. Their stories deserve recognition not because they fail, but because they demonstrate the extraordinary diversity that once characterized humanity. In many ways, modern people continue living alongside these vanished relatives. Every individual carrying Neanderthal ancestry preserves tiny fragments of their genetic history. Certain immune responses, adaptations to climate, and countless subtle biological traits remain connected to encounters that occurred tens of thousands of years ago. Although independent Neanderthal communities disappear, part of their inheritance quietly continues within us. Their legacy extends beyond biology. Every archaeological excavation that uncovers another hearth, another carefully shaped tool, another healed injury, or another family relationship reminds us that compassion, cooperation, and intelligence did not suddenly appear with our own species. They existed long before recorded history expressed in different forms by different branches of humanity. That realization may be the most profound discovery of all. The boundary separating us from them grows thinner with every decade of research. The more evidence scientists recover, the more Neanderthals resemble distant relatives rather than evolutionary strangers. They laugh though we cannot hear it. They mourned in ways we only partly understand. They watched children grow into adults. They waited beside winter fires while storms crossed the frozen plains. They looked toward tomorrow with no knowledge that history would eventually remember them as extinct. For them, life was simply life. Each morning brought another hunt, another journey, another season, another generation. They could not know that hundreds of thousands of years later people would search caves across Europe and Asia, trying to reconstruct the world they once considered ordinary. Perhaps that is the greatest irony. The species that came closest to replacing us never truly sought to replace anyone. It simply lived, adapted, endured, and survived for an immense span of time until the balance of nature slowly shifted beyond recovery. Its disappearance was not the triumph of one humanity over another, so much as the quiet closing of one extraordinary branch while another continued growing. And because that surviving branch became us, we inherit not only the earth they once shared, but also the responsibility to remember that for most of human history, humanity itself was wonderfully unexpectedly diverse. The long Ice Age evening eventually gives way to another world. The glaciers retreat. Forests slowly spread across valleys once covered by open steppe. Rivers settle into new courses. The mammoths disappear, followed by many of the great animals that had shaped the rhythm of countless generations. Human communities begin planting seeds, building villages, raising cities, and recording their stories in stone and ink. By then the Neanderthals are already gone, yet the landscapes remember. The caves where families once gathered still echo with dripping water. The flint scattered beneath ancient hearths remains buried beneath layers of earth. The mountains they crossed continue rising above the valleys, unchanged by the passing of thousands of generations. Nature rarely marks the disappearance of a species with ceremony. It simply continues quietly carrying forward the traces left behind. Modern archaeologists kneel where Neanderthal children once played, brushing away grains of sediment with delicate tools. A fragment of charcoal, a worn stone scraper, or a single tooth may represent months of careful work. Piece by piece, an entire world emerges not through grand monuments or written chronicles, but through ordinary moments preserved by extraordinary chance. Perhaps that is why their story feels so deeply human. It is not only a story about extinction, it is a story about endurance, adaptation, family, and the fragile balance between survival and disappearance. It reminds us that intelligence alone does not guarantee permanence, and that even the most successful societies exist within environments that are always changing. Our own species is the last remaining branch of a once diverse human family. That fact can inspire pride, but it should also inspire humility. We walk across continents where others walked before us for hundreds of thousands of years. Some of their knowledge vanished forever. Some of their bloodlines continue quietly within our own. Their world did not end with a dramatic final moment. It slowly blended into ours until only echoes remained, and perhaps those echoes are enough. When the evening wind moves across a limestone valley, when snow settles over an ancient cave entrance, or when sunlight reaches the floor of a shelter occupied tens of thousands of years ago, it is possible to imagine the countless generations who once considered those places home. Their names are lost, their voices are silent, but their existence reshaped the story of humanity in ways we're only beginning to understand. In remembering them, we remember that our own place in history is neither inevitable nor permanent. It is one chapter in a story that began long before us, and whose quiet traces still rest beneath the earth, waiting patiently for those willing to listen.